Hi and welcome. My name is Fredrik Jansson, and I'm here to take you on a journey through 3 different domains and explain to you how we built a proof of concept for 5G end-to-end slicing. Before we start, I want to give a quick shout out to John Maluli and Victor Leon. Without the 2 of them, this proof of concept wouldn't have happened. With that said, let's move on. So the key takeaways from this is that I want you to take with you is that NSO is the best tool for implementing domain controllers, and that NSO is also a brilliant tool for implementing cross-domain orchestrators. I also want to say, don't forget about the resource manager for NSO, and you will see why during this presentation. The example that I'll use here is around 5G end-to-end slicing in a 5G for enterprise example, but I want to stress that the same techniques we used here can be used to solve a wide variety of cross-domain problems. So first, what do we mean by network slicing in this context? Well, network slicing is fundamentally an end-to-end partitioning of network resources and network functions, so selected applications and services may run in isolation from each other for a specific business purpose. So with that out of the way, let me explain what you see in this picture. To the left, we have the RAN side. I will not go into any details of RAN here, but we do need to configure the RAN PE as part of the transport domain. We have a separate data center for the 5G control plane where we run the 5G apps. The enterprise network is a VPN that we assume exists in the service provider network. And then the idea is to deploy a UPF for a customer in a given SP or enterprise data center. A UPF is a user plane function, which is basically the data plane for wireless. So this is where the GTP tunnel coming in from the RAN side is terminated. And this is also where, for example, a cell phone's IP address is anchored. So while your cell phone can roam between different cell towers, the IP address actually is anchored at the UPF. From the UPF, we need to make sure we have connectivity with the right cost parameters or SLAs. Going to the RAN side, we need to go to the 5G control plane side, and of course, we need to take the data from the cell phone or equipment through the UPF into the enterprise networks. And over the next slides, I'll go through the 3 different domains, data center, transport, and 5G control plane, and highlight each domain's challenges. After that, I'm going to switch over and I'll present how we address these challenges using NSO and Friends. So in the service provider enterprise data center domain, we typically have multiple data centers that can be geographically spread. We typically have a fairly complex MANO stack that could, for example, be ACI or plain OpenStack, which we use in this proof of concept. Given the connectivity requirements we have for the UPF, we also have a somewhat complex network that needs to be built. The UPF in our case has 4 different networks connecting to RAN, enterprise network, the 5G control plane, and then we have a separate management network for NSO. And as something could go wrong either in the VIM or with the UPF, we also need to handle healing of the UPF in this domain. So let's switch over to the transport domain. The transport domain typically consists of a fairly large network. This is typically part of the SP core network. More often than not, we have a mix of Cisco and third-party equipment in those networks. The PE routers that we need to configure as part of the transport domain typically have a fairly complex configuration. And then on top of that, to fulfill the different 5G slice types, low latency, high bandwidth, encrypted link, and so forth, we need to deploy VPNs or segments with the right cost requirements. Then we move into the 5G domain, and this was probably the most challenging for the proof of concept. So let me explain to you what happens here. As a background, the Cisco 5G packet core control plane is deployed as cloud-native applications. In the proof of concept, we are running it on top of Kubernetes. And as part of this proof of concept, we also wanted to show that we could automatically deploy vanilla Linux VMs and then install the Kubernetes cluster on top of those. So as those VMs were spun up, we needed to coordinate with the SMI cluster manager, which I'll touch more upon later what that is, to tell it to deploy Kubernetes on those vanilla Linux VMs. When the K8s cluster is up, each application first needs to be deployed, and once it's deployed, it needs to be configured. And I want you to remember that these applications are spun up and spun down on demand. And it's also further complicated by the number of different applications that need to be deployed in different combinations for different customers and different use cases. So for example, you see that there is a PCF, a policy control function, and an SMF, a session management function, deployed as part of a URLLC, ultra reliable low latency, which I'll refer to as a low latency slice. So there we have a dedicated PCF and an SMF for a customer who needs low latency. In the IoT use case, we are opting to use an existing PCF, a shared policy control function, but having a dedicated SMF per IoT customer. This is really up to the service provider how you want to package that. But this adds to the complexity. As the applications are deployed, they need to be correctly configured for each use case. So these 4 slides has hopefully given you some insight into the challenges that each domain presents. So let's switch into how we address these challenges using NSO. Again, we're going to start in the data center with the data center NSO. And as mentioned before, in the DC, we need to be able to handle multiple data centers. We also need to deploy UPFs with their somewhat complex networking. And once the UPF is up and running, we need to make sure we monitor its health. For this, we are using the Cisco Nano Stack, which is NSO NFVO, the Elastic Services Controller, ESC, and Cisco Vim. With the ESC, you can actually choose to have one ESC per Vim or let one ESC manage multiple Vims. And this flexibility of ESC really simplifying deploying the UPF or any VNF for that matter in the available data centers. Using NFVO on top of ESC allows us to hide a lot of complexity around deploying, creating the right networks, and also configure healing of the UPF. Even though it's ESC that is actually monitoring, we need to configure it. We also make heavy use of the resource manager to allocate VLANs and IP addresses for the UPF for the different networks that we create. I also want to highlight that we do actually not onboard the UPF as a device in this domain, but we actually onboard it in the 5G NSO, which I'll touch upon later. Everything here is made into a domain-specific service that we expose to the northbound. And that is a concept that we have reused across all the domains in this proof of concepts. And we could actually have chosen to expose the NFVO as it is to the cross-domain orchestrator. But we do think that by having a domain-specific UPF, in this case, service, actually gives the organization that is responsible for this domain much more control over what can be done from the northbound. And it also simplifies the consumption of this service from the cross-domain orchestrator. So simply by adding the right abstractions, We give both the organization responsible for the domain more control, but we also make consuming the service a lot simpler from the cross-domain orchestrator. So with that, let's check out the transport side. Here on the transport side, we can potentially have a large set of devices from different vendors. And this we attack as always using NEDs. And I know that this is no news for you, but this allows us to configure Cisco or third-party devices. We're also using the TSDN, the Transport SDN core function pack, which is built to scale, which we need in this domain. But it also adds abstraction on top of segment routing. And that allows us to build the correct or right SRTE segment routing traffic engineering policies. For example, again, for low latency, high bandwidth, and so forth. In this domain, we also need to configure BGP, as the UPF needs to communicate with RAN, with the RAN side for the GTP tunnel. It needs to get the traffic into the enterprise network for the detunneled traffic. And it also needs to communicate with the 5G data center, as it needs to communicate with the 5G control plane, specifically the SNF. Again, we are using the resource manager here to allocate route targets for VPNs, specifically for those VPNs that we create on the fly as the services are deployed. And in this case, the domain-specific service takes IP addresses and VLANs that is actually coming from the data center side into this domain as input parameters. And so with that, let's move into the 5G domain, where there are a lot of things going on. So hang on. In this domain, we use SMI, Subscriber Microservices Infrastructure, more specifically the cluster manager part of that. The cluster manager is used both to deploy the Kubernetes clusters, but also used to deploy the different 5G control plane applications onto those clusters. So it really serves us two purposes here. SMI comes with conf embedded, which is a huge win for us, as we get netconf, of course, we get notifications. On top of that, actually all the Cisco 5G applications come with conf embedded. Again, a win. You get netconf, we get notifications, and those two really simplifies the integration to NSO. These conf-tiers are typically referred to as ops centers, and not only do they provide netconf, they also provide CLI, RESTconf, and other northbound interfaces to the cluster manager and to all applications in case you want to consume this from something else than NSO. Notifications are used both by the cluster manager and the applications to tell NSO what state they're in. So using these notifications, NSO knows, for example, that PCF is now 50% deployed, now it's 100% deployed. And that allows us to write the services in NSO to actually sit back and wait for the application to say, hey, I'm now 100% deployed, and then we can start configuring that application as we would configure any device in NSO. And here in this domain, we actually onboard the UPF that was spun up in a different domain, but we actually onboard it as a device here and configure it as part of the slice. We also built a domain-specific service that simplifies the adjacencies between the different applications that we have. So for example, that service allows us to express that an AMF can have multiple PCF, and a PCF can have multiple SMF, and an SMF can have UPFs and so forth. So it really gives the cross-domain orchestrator a simple way of expressing for URLC, low latency. I want to deploy a PCF, and with that, a specific SMF. Or for example, in the IoT case, I want to add a new SMF to an existing PCF. Here we use a resource manager to allocate IP addresses for the application, and also to allocating slice differentiators, which are coming from the 3GPP side, and are a way of identifying the different slices in this. So let's move into the last domain. So in the cross-domain orchestrator, we built a couple of example services. For example, URLLC, low latency, EMBB, enhanced mobile broadband, which is basically high bandwidth or consumer wireless. And these services are super simple. They take 3 or 4 parameters, including in which data center you want to deploy the UPF. And once that request comes in, the cross-domain orchestrator goes to the data center and say, hey, please deploy a UPF in New York, for example. And at the same time, it will go to the 5G control plane and say, for URLC, I need you to deploy a PCF and an SMF. And once those requests are sent, the cross-domain orchestrator waits for notifications coming from the southbound. And once the UPF is spun up in the data center, that NSO will send a notification up to the cross-domain orchestrator saying, hey, I now have the UPF running in New York. It's ready. It has these IP addresses. It's up on these VLANs. And once the cross-domain orchestrator has that information, it can start proxying, for example, the VLANs of the IP addresses down to the transport side, and it will send the IP addresses down to the 5G side, where we now can configure the SMF and the UPF to have connectivity. They need to know about each other to establish the link. And the same thing on the transport side. It needs to know the VLANs to build the subinterfaces, and it needs to know the IP addresses to set up the BGP connection and so forth. And it also knows from the cross-domain orchestrator what kind of VPN is needed. Is it a high bandwidth? Is it a low latency? And so forth. So all of this is really driven in the cross-domain orchestrator by setting configuration and reacting to notifications from the lower NSOs. Finally, I just want to say that I typically don't see the cross-domain orchestrator as a master over the lower domains. I rather see it as one of the consumers of the services offered by the lower domains. And I also want to mention a really cool feature that you get, and that is fast map across domains. So it's well known that we use fast map within each NSO, but now with fast map across the domains, we can, without any specific code, allow a user to come into an existing low latency service and say, hey, I want to move the UPF from New York into Atlanta. And the cross-domain orchestrator will see that the only thing I need to do basically is go down to the data center and say, hey, move New York UPF to Atlanta. And once that is done, again, through FastMap down there in the NFVO, we'll talk to the right EC and spin it up. We will again get a notification saying, hey, UPF is now up and running in Atlanta. The cross-domain orchestrator will pick up the new IP addresses, potentially the new VLANs, and send those down to the SMF through the 5G domain and down to the transport to rebuild the VPNs, the slight rebuild that we need to accommodate the new UPF in the new location. So FastMap across domains is really, really cool. So how does this apply to you? Well, I would argue that you should start small. The key is really to divide and conquer. Start looking at solving one domain at a time. Work on getting good abstractions in the service that you expose. Try to abstract away as much as you can. This makes it a lot easier to consume it from the cross-domain orchestrator. And this is really where things like the resource manager can help by allocating as much as possible down in the domains and kind of hiding that complexity from the cross-domain orchestrator. And then you can use the built-in primitives in NSO, like service plan change notifications and notification kickers and so forth to drive this flow in the upper NSO. So thank you for listening to me. Thank you for listening to me. I will now be available for questions. Thank you.
battling a smoke detector. So I am winging it for Q&A. So, Fredrik, let's start with the basic. There's a lot of cool capabilities and technologies we talked about. How do I actually buy this? Is this in a neat little packaged box? Where do I start? Kind of what's the guidance for folks that are really interested in this and want to try applying this in their environment?
Well, the 5G function pack that I touch upon is something that we're working on at the moment. We are aiming to have a first release out of the core function pack in the October timeframe, and happy to answer more questions on around that if you want to reach out to us through your account team.
Sure. Yeah, absolutely. For all these things, reach out to the account team. I think most of the speakers are also available through the app, so you can chat with them directly. Nicholas also wants to make sure that you guys are answering the polls question. So while you're between questions, please answer the poll. You can see the results from the poll once you answer. So, Fredrik, you talked a lot about cross-domain, and it certainly seems that's very central to what we're trying to do here. What are some of the challenges when you're trying to orchestrate across multiple domains like this?
Well, I mean, there are multiple challenges, right? Each domain poses its own challenges to itself, as I said in the presentation. But then, to really utilize the domain controllers, if they're NSO or something else, you would typically want to build an end-to-end service sitting on top of that. And typically in a perfect world, you could just send the intent everywhere and it would just work out. But it turns out that you really have to spin up a VM like we do here and actually wait for that to come up before you can proceed. I think that is still a challenge that we have. I think NSO does a great job helping you solving that problem through notifications and nano services and driving that forward. But I think that was the biggest challenge we had in this proof of concept, was really make sure we orchestrated the domains that we had.
Sure. So, and one of our claims to fame is multi-vendor orchestration automation with NED. So, is it safe to assume if there's a NED or we can build a NED, we can work that gear into an end-to-end slicing scheme, or are there other things that we need to be paying attention to, or are there other restrictions?
No, I think if we can build a NED, we can, if we can talk to that domain controller or that device through a NED, in a perfect world, it can generate notifications to us to drive it. If that's not possible, we can poll it. So I think as long as we can talk to it from the cross-domain orchestrator, we're good.
Cool. And we're talking not just specific hardware, right? We can control other controllers, maybe some even cloud-based resources, those kinds of things. So there's potential a lot of flexibility here. Okay, cool. So along those lines, I know we're also all about netconf yang and the like. So is this restricted to netconf yang? Can we manage other types of things? And along those lines, do we see netconf yang being more widely adopted as customers go to 5G and start a refresh cycle for their hardware?
I mean, absolutely, yes. I do think we're seeing netconf taking off in many different domains. Foremost, of course, still in the transport domain or for the routers and so forth. But I mean, again, all our 5G applications that Cisco built, including the controller for that, the SMI cluster manager, all come netconf ready, and that really simplifies the integration with NSO. You basically get integration with NSO for free. You get the NEDs for free. They can generate notifications, which makes that driving I touched upon earlier really simple. But again, I want to stress that other vendors may not have that, and again, as we said, as long as we can talk to whatever that is through a NED or something else, we're good. So it helps, but it's not the only thing.
Cool. So I know you've spent a lot of time talking to customers in terms of developing the solution to that point. What do you see as their kind of their leading use cases and their kind of biggest challenges around moving forward? And for the folks that are watching, what can they learn from the customers that are kind of the cutting edge of this?
Good question. I think that one way to take away from this is really the effort we put into making each domain easy to consume. I think that was one of the key things. Abstract away, use all the tools that we can provide around NSO, or tools that you have to simplify the consumption of this.
Okay, cool. And prior to prior to the release of our core function pack, the access, any other reading, any other things customers can be doing to come up to speed? Who else should they be talking to organizationally? I mean, this is not just an infrastructure thing. It ties into other parts of the business. What other conversations do we need to be having from a process perspective?
You mean to get into something like this yourself?
Yeah, I mean, who else? I mean, within the organization, right? It's not just setting up the infrastructure. Should I be talking to service creation folks? Is there, should I be talking to the OSS, BSS folks? Who are the other stakeholders when you turn up something like slicing, from your experience talking to other customers?
Oh, okay, great question. I mean, so just in this, right? It's a proof of concept, but I mean, we were touching about on 3 domains in here. So you would have to talk to your core networking guys. You would have to talk to your data center team about, in our case, spinning up the UPF. You would have to talk to the team responsible for your packet core, if it's a 5G, 4G use case. And then, of course, this has to be consumed by an OSS and BSS system. So all those teams would have to be involved one way or another. But again, I'm keep falling back on the domains, and I think again, you can work with each team and have each domain present an API that the cross-domain orchestrator can consume, and you as data center team, for example, can really make sure that is an API that is the API that you want your internal consumers to use.
Okay, that makes sense. Last question, and this is, you get to Pine. This is an easy one. So we've talked about this specifically from a service provider perspective, but do you see enterprises using slicing directly as part of the way they deliver apps, or do you see it always being a behind-the-scenes thing a service provider provides to their customers?
No, so again, I can't say I'm a 5G expert, but I mean, we do see enterprise use cases for 5G in mines, in factories, what do you call those, like PG&E type of companies, utility companies. So I think there will be a lot of interest in 5G from enterprise companies as well.
Okay, cool. Well, thanks, Fredrik. I think this was very cool. I think that's it from here. Back to, I think, Nicholas. I hope.
Thank you, Omar.
Yeah. Very good. Thank you, Fredrik. That was great to hear those insights on the 5G slicing. And thank you, Omar, for asking those questions.